about tools at various levels in the computing environment, all focused around enabling high throughput computing. And so I'm sure it comes as no surprise to everyone on the call here that the network is obviously a key ingredient in the environment, probably the most important enabling technology in the system. And lots of symptoms arise when there are network troubles. And so I thought it would be good to have Sean McKee from the University of Michigan give us a presentation about tools and experiences that have found good use and been very effective in supporting high throughput computing. So I will turn it over to you, Sean.
Okay, thanks, Rob. So I have my presentation up, so if people raise their hand, Rob will have to catch it, as he mentioned. I guess there should be opportunities for discussion as we go along, but as Rob said, if you can wait, we can catch them at the end. Otherwise, raise your hand and let Rob know so he can unmute you. So the abstract that went out was basically this. I don't want to read through it. The important point is that for Open Science Grid and grids in general, the network, as Rob mentioned, is very central. It underlies everything we do. And when there are problems, it can be a real problem to find them in an end-to-end system where you don't have complete visibility. So what I'm going to cover is shown here. I want to give a brief overview of Open Science Grid, campus grids, and networks problems, talk a little bit about understanding the overall system and how we categorize problems and localize them. Then I want to talk some about perfSONAR-PS. It's your friend, and I'll tell you why and how it can help you. I'll go through some details about the perfSONAR-PS toolkit, its installation and configuration, using perfSONAR-PS when there are problems, and I'll do a brief walkthrough of documenting a problem. And then at the end, I'm going to conclude with some summary and resources for going further. So in terms of OSG, network monitoring is really important. And the reason is that in distributed collaborations, the network is a critical part of our infrastructure. Yet when there are problems in the network, it can be extremely difficult. And we've had cases that have taken months, if not years, to resolve. Also, the network is pretty basic and fundamental. And there's not a significant differentiation of how the network is used amongst the various OSG users. The quantity, of course, may vary, but the use cases are pretty much very similar. What we really need is a standardized way to monitor the network and locate the problems quickly when they arise, if they arise. We certainly don't want to end up in a situation where every VO has its own network monitoring system and we're all sending traffic through the network and monitoring it with our own applications. That just doesn't make sense and certainly wouldn't scale. So in general, data movement for science is, of course, the big issue. And flows are getting larger. Science data sets in the research and education world are getting much bigger. There are sometimes special requirements. Streaming media is very sensitive to jitter. And of course, bulk data transfer is sensitive to loss. There's a large and increasing number of users and devices. And the locations are spread out, in fact, globally. Everything ends up being cross-domain. So the little picture is, if you're a fan of Spinal Tap, you'll recognize the 11. Open Science Grid, campus grids, and network problems. So the fundamental goal of Open Science Grid is to advance science through open distributed computing. Underlying Open Science Grid is a robust network that ties everything together, all our distributed compute and storage resources. And grids in general also assume and in fact require a ubiquitous and high-performing network that interconnects all those relevant resources. The real issue is what happens when things don't work as you planned. So in many cases, there's users and local administrators who have to slog through a daunting, potentially long period of trying to diagnose, debug, wait to get some sort of resolution to a distributed problem. The network is, of course, often blamed. When it doesn't work and the network's involved, usually people say it's a network problem. But it's not always the issue. If it is the network, you have another problem. Networks span a number of administrative domains typically. So which part is broken? Where? What is actually broken? Those are hard questions to answer when you don't have access to and control of all the components along the path. So some network realities. So where are the problems? They could be in the network core. So we assume, of course, that everything's well connected, well provisioned, flawlessly configured, right? Obviously, that's not always the case. What about the end systems? Are they properly tuned for optimal TCP performance? Doesn't matter what operating system you're talking about. Do you have all the proper drivers, everything functioning optimally? Right? That's always the case. What about the LAN? What about the regional networks? The questions go on and on. So really, it's almost better to ask, where aren't there problems? Seems like every time we look, we find an exposed problems. So the real goal here is to understand distributed infrastructures. As noted, when problems involving these distributed resources occur, the first thing to get the blame is the network. And sometimes that's even the right answer. The problems span a wide range of symptoms. There's loss of connectivity. Those are usually easy to find and diagnose. But harder are poor utilization of the network, intermittent connectivity, or wildly varying performance, funny application errors, or basically misbehavior of applications. And these can be very hard to diagnose and find the real root cause of. So grid systems and campus infrastructures are also, as most of you know, very complex, and they involve many moving pieces. And network diagnosis itself is non-trivial for many reasons, not the least of which is that all of these network connections typically span multiple administrative domains. Nobody along the path usually has complete visibility into more than their part of the path. Maybe they have some access to their neighbor's information, but usually there's no one entity that has full visibility of the end-to-end path. So really the critical issue for all of us is to understand even approximately where the problem lies. That way we can work toward a solution much more effectively. So the possible where. When problems arise in these distributed systems, there are many possible sources since they can be anywhere in an end-to-end sense. So the first step is to understand if it's the network or the end system. That's a logical dichotomy. Is it in the middle or is it on the end? Of course, this can be really subtle. Sometimes you have local network issues that really aren't visible when you're doing local network things. But as soon as you try to make connections across the wide area network, things break or perform very badly. And you attribute that, of course, to the wide area network. In reality, the problem could be on your local network, and it's just not exposed until you try to do things across the wide area network. Likewise, if you have a poorly tuned host or ones with faulty hardware, in a local area network setting, they might work okay. The problem might not be very visible. But as soon as you go to WAN connections, you see very bad performance. And again, the tendency is to blame the WAN, when in actuality it could be the end systems. So what to do? You've got users and local administrators and network engineers faced with the dawning issue of trying to track down problems where they have limited information and access to the full end-to-end path. So the general strategy is to divide and conquer. First, let's start out with examining the end host for problems and misconfigurations, and then try to measure some characteristics of the network path involved. So in terms of end hosts and application, as I've mentioned, many of the end-to-end problems are actually issues at the ends. So the good news is that users and admins usually have access to and experience with end systems. There's something they can get their hands on, and they understand them usually, certainly at a much better level than they typically do of the network. So one important aspect of the end systems is to understand how the network host has been tuned. How has the network stack on particular host been tuned? How are the drivers, firmware, and the application all interacting with the network? For example, applications can be designed poorly in terms of wide area network use. They can have poor buffering set up. They force small buffers when they make connections. They do many small latency-sensitive transactions. There are many failure modes for applications that weren't designed with any intent to use the wide area network. Nonetheless, people try to use them on the wide area network, and they can be the source of problems that appear to be wide area network problems. There's sort of an end host application checklist. I'm giving a very brief overview on this because this could actually be a whole other webinar, going into all the different things that you can look into in the end host. Basically, some rules of thumb to go through. Check for errors and faulty hardware. Look at your logs. See if anything is reporting something unusual. You should also have a pretty good idea of how your host actually connects into your local area network. Is it on a hub, on a switch? Do you know anything about how it was configured to talk with the network and configured on the network? There are some tools from the command line. These are specific to Linux You can use ifconfig and ethtool to gather some network and network interface info. For example, ethtool with a -F and the name of the NIC will give you the NIC stats. And for example, you could run that command, save the counters that it shows you, run your problematic application, and then run this again and compare the difference between the before and after and see which counters are incrementing from the point of view of the NIC. Another obvious question to ask is, has the application in question worked before? Is there some different way that you're using it now and seeing a problem as compared to previously when it actually seemed to work? There's a lot of good information on ESNet's page. They have in investordata.es.net, there's a host tuning section that'll give you a lot of information about how to tune up hosts with various operating systems. What we really need, if you've gone beyond the host, you've checked it, the setup seems okay, it's tuned okay, but the problem is still there, what do you do? We really need some sort of finger-pointing tool that can help further isolate where the problem may be. So the real question is, how can we quickly identify when there are problems that are network problems and isolate the location of those problems? So really, the perfSONAR project was designed to help do this. So there's a number of motivations for network monitoring. Basically, there's two distinct steps for finding a solution when there are network performance problems. You need to use some diagnostic tools to help locate the problems. There are tools that actively measure the performance, meaning either the latency, the available bandwidth, the packet loss, etc. These are all active tools. There are also tools that passively observe performance. So there are counters on the hosts and in the network devices that will record errors or packet discards or other information. And we would actually like to have access to both of those. Of course, it's in the second case, the passive metrics that might be available aren't always accessible. In fact, most networks won't actually let you get at that information. They will use it for their own diagnosis. Of course, the other part of it is, in addition to this sort of set of diagnostic tools, you should have some sort of regular monitoring so you understand what the baseline performance that you should be expecting, what it is, and then look for deviations from the baseline. So something has changed and perhaps there's a problem that needs to be responded to. So basically, the regular monitoring can happen because you take the regular diagnostic tools I mentioned above and you use them in a structured manner. Typically, you'll set up scheduled tests at a regular time cadence and then record the data and track it. Of course, you need visualization and alarms to then look at that collected data. So incorporation of either of these techniques must be ubiquitous. We really need that sort of information available everywhere along the path. And of course, seamless. As I mentioned, many administrative domains will collect a lot of information, but they only use it internally. And it would be much better if there was some way to expose information that they were willing to expose to help debug end-to-end systems problems. So a little bit about the history of perfSONAR. perfSONAR is a joint effort of a number of institutions, ESNet, Internet2, Géant, and Dante, and in Europe, RNP, and many others, to standardize network monitoring, protocols, schema, and tools. So perfSONAR as a project provides a common way that we can define network metrics, and it makes implementations able to share data and interoperate. So there are many research and education networks worldwide that have adopted perfSONAR as the standard way to gather these network metrics. So the example I'm going to focus on in the rest of the talk is the implementation from Internet2 and ESNet. It's the perfSONAR-PS version of perfSONAR, and they produce a toolkit, and that's what I'm going to cover. So here's an example perfSONAR use case. perfSONAR should be used to diagnose end-to-end problems. So you have a user and a resource. The user is attempting to download from a remote resource. There's some distance between the user and the resource. This is a wide area network transfer. We're assuming that the user and the resource are both connected to high-speed networks. But the operation, nevertheless, doesn't go as planned. So where do we start? So one of the first things to do is a very simple trace route. That'll give us the path that the data would be flowing over. And of course, the performance problem could be anywhere along this 4-segment path that's shown in the diagram. The problem could be something that we could fix, we being the user, but chances are much greater that we wouldn't be able to have anything that we could do about this problematic path. So if we go on, one nice thing would be if each one of these administrative domains, colored differently along the path, would provide us with contact information, or even better, some information about how they're performing. So that's where perfSONAR comes in. So in this case that I'm showing, each of these domains has made some measurement data available via perfSONAR. And the user was able to discover this automatically and then use some automated tools, visualization and analyzers, powered with this network data. So in the end, the problem can be isolated based on this testing. It could have gone unnoticed in the local domain, some sort of soft failure that nobody actually saw being a problem until the user pointed it out. It could have been observed by others already, but maybe nobody else reported it up till this point. So the user can contact the specific domain in question to inquire about this particular problem. And the really nice thing is that when the user goes to reach out to that administrative domain, he has some good data that he can provide to the network engineers to show what the problem is and what the user saw. And that should really help expedite a solution. So what does, in general, perfSONAR-PS, this toolkit that I mentioned, provide? So when you install perfSONAR-PS on a host, you get a number of tools and options. The instance can be configured to perform regularly scheduled tests, like bandwidth tests, controlled by something called BWCTL, a latency packet loss test, configured and controlled by something called OAMP, traceroute tests, and pinger tests, round-trip time. In addition, there are on-demand, it serves as an on-demand test point for any of the above tests. And furthermore, there are additional built-in diagnostic tools accessible via the web. There's something called NDT and there's something called NPAD that, if they're enabled on the perfSONAR instance, can help end users debug problems. So here's a little bit about installing a perfSONAR-PS toolkit. One of the first steps you need to do is identify the hardware that you're going to use to host the toolkit instance. The recommendation in general is that sites instantiate two instances, one for latency and traceroute data and one for bandwidth. Of course, you need to get DNS names and IP addresses for these instances. One important thing that I didn't mention in this slide is that hardware has to sit someplace, and the recommendation is to sit as close to the end site storage resources as possible, because that's typically the interesting data path that we want to understand to and from site storage. Could also, of course, be co-located with the compute farms, the clusters. In either case, you want to make sure it has basically as end-to-end a path as you can give it. So you'd like it next to some important resource that will use the wide area network. So then you can install this on the host that you've identified and gotten an address for. It can be installed either via net install image. There's an ISO image that you can put on CD or Pixie Boot, and that will install onto the local system's hard disk. At that point, you have an installed perfSONAR instance, and you can update it with Yum. The other option is to treat it like an appliance. So you can get a different ISO for either a CD-ROM or a USB, and you can then boot the host from the CD-ROM or USB, and you'll come up and you need to do an initial configuration, which will get persisted to the local hard disk, but basically it will run off the CD-ROM or USB from then on, and it'll just keep its configuration information written locally. Of course, after you've done this installation, whether you chose net install or an appliance type install, you need to configure it. So in terms of configuring perfSONAR-PS, there's some details in the quick start URL above, up here, that I showed before. But basically, one of the first steps is to supply some administrative information. So on the left-hand side of the web interface, you'll see a little box that looks like this graphic on the right. There's a toolkit administration box with something that says administrative information. So you're going to need the credentials that you configured when you installed it. You click on this, it'll prompt you and then take you to a screen where you can do some configuration. Some important points, in addition to, of course, your email and the person responsible for the host, you want to put in an address or a location suitable for finding in Google Maps. So ideally, we would like to be able to resolve that into a latitude and longitude with some of the services that are available. In addition, any one of these perfSONAR instances can choose to participate in communities. And communities are a very simple concept. It's a way to say that you're part of a certain community. For example, if you're part of one of the LHC experiments, you could be in the community LHC. If you're part of the Atlas experiment, you might be in the community Atlas. These are just strings that are used to help instances find each other. So in effect, there's a lookup service that can find everybody else who's a member of Atlas or LHC. And you can easily see where their instances are and then set up tests in a trivial way to them. So the next step after you've got your administrative information in place is to configure the services that you want to run on the particular host. So as I mentioned before, the recommendation is for two types of host, latency or bandwidth. And there's some simple little buttons. This is the configuration screen shown in the perfSONAR toolkit. At the bottom you see it says only enable bandwidth services or only enable latency services. So there's sort of a one-click config to set up the right services for either of those modes. Of course, users can then augment the default, say, bandwidth configuration by adding some additional features. For example, the NDT and NPAD services that I mentioned are shown in the list. They can be added to either or both of the bandwidth or latency instances. SSH is another one that can be turned on or off for both instances. That would allow you to SSH into the host to configure it. So here's what the front-end web GUI looks like once you've done an install. At the top, you can see I outlined the box where the host information is. This is my instance here at in Ann Arbor for Atlas Great Lakes Tier 2. And underneath that, you can see there's a few different communities that this host participates in. As of version 3.2.2, maybe even 3.2.1, the toolkit will automatically become part of the versioned community. So you see there's a community there called ps-npt np-toolkit-3.2.2. And so that's automatically added by the install. The other ones were added by me to participate in those communities. Underneath here you can see the various services that are running on this host, running or disabled. So I mentioned before this NDT and NPAD. These are some of the on-demand services that you can use to make some tests with. So NDT is an interesting diagnostic toolkit, and you can invoke it from any web browser which supports JavaScript. And you just need to point your browser to the host's DNS name with port 77123. That will then pop up a little window where it will have a little JavaScript applet that you can click Start on, and it'll run a 20-second test. Very similarly, there's another application on here called NPAD for Network Path and Application Diagnostics. It's running typically on port 8000. Both NDT and NPAD analyze the network by watching what happens while tests are done, and the fact that the perfSONAR boxes come with a Web 100 instrumented TCP stack is what allows them to really understand what's going on in the network. So Web 100 is a way of exposing what happens in the Linux TCP stack to higher level applications. So you can get a lot of information about what TCP is actually doing as these tests are running. And both of these applications can then analyze that and give feedback to the user. So remember, both of these things are to test the path between somebody's desktop or browser and the perfSONAR instance. I should also point out that Open Science Good distributes CLI client versions of the tools above to allow running from the command line. And there's a URL here that you can use to get some more information about the client tools. So in terms of using scheduled tests, that's sort of the next level. Most sites installing perfSONAR-PS are going to want to set up some regularly scheduled tests to other relevant sites across the network. So these would be sites that you typically interact with, you exchange data with, you work in a grid with, they're part of a collaboration with you. The idea here is to create a baseline to compare to, so you understand what's possible between your sites and what the current situation is. Of course, it's even more useful because it can identify when and where problems occur. So to set this up in that same toolkit administration box on the left, you click Scheduled Tests, and you can go in and set up the tests. Again, if everybody's participating in a community, sometimes it's as simple as clicking on the word for your community, and it'll show you the list of all other instances that you could be testing against. And you can simply check them off and add them to a test. So it's pretty straightforward. Here's an example of what OWAMP tests look like on one of my hosts. Now it's truncated, but you can see that there's source and destination here. It says whether the test is bidirectional, whether it's being run both ways. And then it shows columns for forward direction loss and reverse direction loss for the past 30 minutes. On the far right, there's a graph option where you can drag down a box and pick the last 4 hours, the last 12 hours, the last day, or the last week. So an example of popping up one of those graphs for one particular source and destination is shown here. This is the 24-hour result from OWAMP between BU and AGL Tier 2, between Boston and University of Michigan. So this plot shows results in both directions. It's a little hard to see, but there's a blue line up around 14 milliseconds and a red line above 14 milliseconds. And that is the one-way delay in either the blue line corresponds to let's see, that would be BU to Michigan, and the red line corresponds to Michigan to BU. And you can see that it's symmetric. The path looks symmetrical there. By the way, the deviation that you're seeing is probably due to clock drift. So those are differences in either the source or destination clock relative to each other. You can see they average out to be almost the same. If you take the average of the two, you get a symmetric path. The interesting thing on this plot is that there's some indication of loss shown here. And on the right-hand side of the plot, you can see the loss percentage. So there's some peaks in there that are pretty high losses, up near almost 14% in that one case about 5 a.m. So this path isn't great, but it probably would work okay. There aren't that many events over a 24-hour period where we actually saw some loss. So in general, not too bad. Here's another example between Southwest Tier 2 and AGL Tier 2. And here you notice a couple things. First of all, the path is not symmetric. So we're getting a different one-way delay in one direction compared to the other direction. And another interesting thing is you can see it significantly changed on the far right there. The blue line dropped way down below the red line. So something significantly changed in the routing there. The other thing to note is that the loss here is more frequent, and this would probably have a much larger impact on throughput. The total amount of loss is small, but we're talking about a larger round-trip time, and the net effect of having all of these loss events would probably be bigger on your achievable throughput. So similarly, you can set up bandwidth tests controlled by BWCTL, and here is a similar page on the other instance. Shows source and destination and some information about all the possible tests. Again, there's a drag down on the right where you can select graphs to see. And here's one example. This is between, this is actually within Atlas Great Lakes Tier 2. This is between Ann Arbor and East Lansing. And you can see the source to destination line is blue, the destination to source line is green. One thing to note is that these are obviously both 10 gig NICs. So we're getting up around 4 gig. Sort of when it's good, bursts up to 5. And then another thing to note is that you're seeing a lot of variation. And in our case, this is because we're actually flowing a lot of other traffic through much of this time period. So you're seeing periods where we're almost fully utilizing the link between the two sites. Here's another example that I looked at for the last 3 months. This is Michigan to Japan. And here you see a couple interesting things. Well, one interesting thing is that my graph is not showing up correctly. It's a little truncated at the top. But there's a period where there was no source to destination test. Japan was not testing to Michigan until about the end of November. And then that came on and they were up near 500 megabits a second. And then all of a sudden, near the end of December, right around Christmas time, something changed in that direction and the throughput got much worse. So this is actually something that we need to look into and see what's going on here, because we dropped by about a factor of 5 just before the new year. So here's another example of how you would use it. The earlier one that I gave showing that there was a hypothetical problem between a user and a remote resource is one thing. But here's what will follow here is an actual use case that we saw in US Atlas. There was some really poor performance between Indiana and Oklahoma, and we used perfSONAR to help isolate that. So when we started looking at things, the first thing to note was similar to the plot I showed, there's in the one-way delay measurements, there's a significant difference between one direction and the other. This almost certainly indicates that there's a different path in one direction compared to the other. So really, that's not a problem by itself. You can have asymmetries in routing, and they can be intentional, and there's no reason to worry about that fact. However, oftentimes it can be correlated with issues for whatever reason. So it's, as Jason noted here, it's only a problem if there's a real problem on either side in the path. So if only one side has a problem in this asymmetric setup, think about who complains, uploaders versus downloaders, right? Who's waiting for the data, who's waiting for the network to respond quickly. They're the people who are going to complain. So the first thing to look at is, what does the bandwidth say? So you take a quick snapshot and you look and you see that the source to destination, right up over 900 megabits a second on a gigabit link, that's great. Destination to source, much worse and more variable. So you're seeing anywhere from 100 to 400, more typically around 200 megabits a second. So it's not as good. One of the paths is doing poorly. So let's look at a little longer time scale. The part that we just looked at in the previous graph was on the far right here. You can see some interesting things here. The source to destination was really good a while ago, got bad for a while, and then got good again. The destination to source path has been bad for a while. So what's the possible solution to this kind of behavior that we see here? Well, a first easy test to do would be to try to alter the routing so that you get the same path in both directions. Hopefully both directions using the path end up on the good path, not on the bad path. Of course, what you'd really like to do is fix the bad path. And again, that requires you to divide and conquer until you can find the one location that has some sort of issue. Should note that often both of these things are done together. However, it should be noted that nobody should just change the routing to avoid a problem and not tell anyone, because that leaves the problem still in place and certainly somebody else is going to be hitting it. So here's an example of what happened after the routing changed, and you can see the destination to source routing was changed to match the source to destination. The latency actually went up because they're both taking the longer path. So what ended up happening to the bandwidth? So the next bandwidth test that we saw looks much better. It's up near 900. So did that stick? We waited a week later, verified the latency was still the same. Paths were going both directions on the same path. And if you look at what happened in terms of the bandwidth measurements, you can see everything is much, much better. Both directions are now up near 900 megabits a second. So in general, here's a checklist for network issues. Check the end host for issues. Use some on-demand tests to verify that you have a problem. Then look through any schedule or existing network metrics that you have, looking for problems. The goal here is to gather the relevant data, anything about the application, host info, the source destination IPs, any network metrics you have, a rough description of the problem, and contact your local networking people with that information. If that doesn't work out, or if they're not sure what to do, there's some backup provided by both Internet2 and ESNet. You can email to either of these and provide them with the information above, and hopefully they can help out. Of course, it's important to probably contact the one that's relevant. So most universities should end up probably contacting Internet2, unless your problem is also going to some national lab or something that ESNet serves. There's a good overview of the troubleshooting process on the Faster Data web pages at ESNet. Those can be very useful to refer to, and they're maintained and updated. So in terms of the future, Open Science Grid, I should let everybody know, has a new initiative as of last year, started in 2012, in networking. And the goal here is to provide tools and services to support OSG sites regarding networking. We're in the middle of producing a new troubleshooting document. It's about 75% done, and will show up on the OSG networking pages that I list at the end of the talk. I should also mention that there's a new project in GitHub focused on creating a modular dashboard. A lot of the data I've shown you is retrieved by going to individual perfSONAR nodes. One thing that's really important is if you have a bunch of nodes that typically work together, they're all part of the same virtual organization, for example, it's sometimes very useful to have a separate entity gather all the data about what's going on, what the network metrics are between those end hosts, and present it in a nice, easy to visualize way so you can see where there are problems or issues. And that's listed at the URLs at the end of my talk. Of course, perfSONAR-PS is going to continue to develop to meet the needs of its users, and certainly they appreciate feedback and any input from all of us. So to summarize, network issues can be difficult to understand and localize. End users shouldn't really be expected to fix network problems, of course, but they should be expected to report them with enough detail to allow the experts to actually do the fixing. perfSONAR-PS is a central component for finding network problems. I encourage everybody to deploy it. It can help you and others find and fix network problems. And of course, the last point is to make sure you know who to contact when you do have network problems. So I'm going to stop there, take any questions or comments. Thanks for listening, and I want to put up my useful references page here.
Okay, very good. Very good, Sean. Thank you. That's an excellent presentation, and I mean, I've seen, of course, many of these tools before, but this was nice to see it all in one nice presentation like that. So I'll open the floor to questions.
So Sean, for the hardware that you deploy perfSONAR on, what sort of specs should they have? And I assume that you'll need a physical machine, not a VM.
It's correct. I will give you some of the caveats around that. So you can use a VM if that were the only thing possible. So I guess what it comes down to is if you run these toolkits on VMs, when you do see a problem, there's always a lingering question about whether it's something related to the VM and the environment the VM is in, or if it's something that you're actually measuring on the network. So to avoid that ambiguity, it's probably better to have real hardware, but certainly not required. And I will also say that virtualization systems have gotten better. Certainly 3 years ago, there were lots of problems seen installing perfSONAR-PS on VMs. Lots of superfluous things happened that weren't at all related to the network, but looked like bad network metrics that were actually the result of problems in the virtualization technology. So things have certainly gotten better, and some recent tests have shown reasonable performance on VMs. Still, we recommend that you use physical hardware. If you go to the Faster Data website that's shown here, or if you actually look back in my talk, I'll bring up that section, there's a recommendation from ESNet about what kind of hardware. This link at the top shows sort of a rough idea of the hardware required. For US Atlas, we've converged on either Dell R310s or Dell R610s. They're on, for sites that are LHC sites, they're on the LHC portal. The R310 is about $900, and the R610 with a 10 gig NIC is about $1,600, $1,500, somewhere in there. So that's still not free, and it's not cheap, but they've worked well, and we've sort of converged on those for the tier 2s and tier 1.
Okay, other questions?
I see a question in the notes. Switch is asking if there is.
There is an RPM repo. Currently, version 3.2.2. I'm pointing at here because it's in release candidate 1. Version 3.5 and CentOS 6, and as well as having 32-bit and 64-bit versions. Those repos exist and can be installed. And so in principle, you could do something like install your own OS and point to those repos and install the meta RPM to get all of the perfSONAR toolkit capabilities deployed. The potential issue there is that there is some gluing together of the services that happens as part of the toolkit deployment that might not be fully replicated when you do an RPM only install. But there are some instructions that can get you pretty close, and they're fairly simple. So yeah, if you want to use an RPM repo and just install your own OS, you can do that. I should also note that those dynamic tools that I mentioned, the NPAD and NDT, they require either a Web 100 or a Web 10G patched kernel, because they do need to instrument the TCP stack so that you can analyze what's happening as data is moving in and out of the host on the network. So what that means is there is an Internet 2 repo that stores the Web 100 patched kernels. And so they track the CentOS kernels, I believe. And when a new one comes out, they will then rebuild it to be Web 100 integrated and put that in their repo. So that typically happens fairly quickly, usually within a day or two. But if some sites have security issues where that would be a problem, they at least have to know what the policy is.
Just FYI, I'm muting everyone and unmuting in between question and answer, so there's a little bit of a delay here. Although it sounds pretty good right now. Other questions?
Yeah, Sean, are there any plans on getting the RPMs into the OSG repos or incorporating them as part of the OSG software effort?
There is. Longer term, we have discussed trying to repackage the perfSONAR-PS toolkit in an OSG flavor, so it would be distributed as part of the OSG software stack. We're still working on some of the details for that, so I think the version 3.3 will be the first version that we will try to do that with. It really makes sense to do that, of course, only if we're doing something that's OSG specific in terms of the repackaging. I guess you could also make a case that it's just useful to have another place to get them from. And certainly at a minimum, we're going to make them available from OSG repos as well as, where you can currently get them off from either Google or Internet 2 or ESNet. But yes, that is part of our plans, to provide that. And in fact, the other thing that we want to be able to provide is this new modular dashboard, both as a service and potentially as something that sites or VOs could install if they chose to go with that.
Speaking of that, I was wondering if you have idea of the law that would put on the gatekeeper or on the cluster in terms of network resource. So if a site administrator is asking what would this imply, both in terms of load on the network and in terms of...
Right. Two good questions. So first point is that we don't recommend that you install this on nodes that are running other services. And the reason is not because we're worried about those other services, but more we're worried about distorting or polluting the measurements that we're trying to get from the network. So the goal here is to have something that's actually telling us as much about the end-to-end network path, excluding the end hosts, as possible. So ideally, we would like to have the latency and bandwidth hosts just be running perfSONAR services and tests. And what that does then is it allows the daemons that manage and schedule and control the tests to basically control the resources of the host so that there's no interference from other activities on the host. In terms of a load, a latency node sends 10 packets a second to every other partner that it's testing against. By default, nobody's tested against until you configure it. So the user that installs it gets to choose how much testing they want to do, both for the latency and for the bandwidth host. So there's 22 byte packets going out 10 times a second. The total load for, say, a reasonable number of tests, something like 20 20 different hosts that you're testing against, I think it works out to 5.4 kilobytes a second of latency data. The bandwidth tests are also, of course, configurable. The default that we're recommending for WLCG now, and that we'll also recommend for OSG, is a 30-second test done every 4 hours with everybody you're testing against. The way the test works is Site A will test to Site B in the A to B direction and the B to A direction. In addition, typically Site B will do the same thing. So in a 4-hour period, there are 2 tests each direction that end up running for 30 seconds. And those tests try to use, well, they're basically trying to measure the available bandwidth. So they're trying to use all of the bandwidth that's available. Using TCP, of course, it shares. But nevertheless, you can expect, as I showed in the Indiana-Oklahoma test, in those were 20-second tests, they were able to reach 900 megabits a second in that 20-second test. So you get a little burst of traffic when it tries to make a measurement. And that happens once every 4 hours for each pair in each direction. Actually, twice that, because each end does it. So the load isn't, still, if you work out the numbers about the total bandwidth consumed, it's not that large. And we have there's a natural point that we seem to have reached. Some sites would rather have much higher testing because they'd like more timely information about what's going on with the bandwidth. And other sites think every 4 hours is still too much. So it's up to the users that install it to choose how much testing they want to have their hosts do. And there's ways that you can control that bandwidth, which I didn't point out, but in the configuration you can set limits on the amount of testing in terms of either bandwidth or number of hosts or other things that you'll allow for your instance. But the load is not really that large. And again, it shouldn't be on a box that's doing other services just to keep those results as representative of the network as possible.
Hey, Sean, I have a question. Oftentimes what will happen is a faculty member will come to me and say, my network is slow. And, they could be doing, sort of any sort of task. I mean, they might be reading their email, they might be doing web, they might, they might be running, an application and so on. So, and oftentimes, they might actually not even be aware of where they are on the campus infrastructure, what host they're on, or if they're, what they should expect. And I was just wondering, I mean, we have found these tools to be extremely useful for, from the system side, looking at throughput bottlenecks, looking for network problems. I mean, we use these, on a nearly daily basis now. The folks that are submitting jobs and, trying to get, they might be trying to pull data off the network. They might be running a global from their desktop, downloading data from other systems. Is there any idea in this project to maybe make more of a user-centric view? I mean, I'm hesitant to point folks to these pages who are end users because people, they're just submitting jobs. They're just trying to get their work done, and they can look at them a little bit, but usually they're not. They don't have necessarily all of the language. They may not know what bandwidth control tests mean and so forth. Is there any notion? I mean, it seems like there's sort of a gap between what a user might be experiencing, and how they can actually gather some information to even hand to their local system administrator.
So the two tools that I mentioned, the NPAD and NDT, are a good thing to point people at because from their browser or their command line, they can run a test. Yep. So can you see this window? So this is our perfSONAR node for the Tier 2 here at U of M. You can click Run, Start. It'll run a little test here. It's going to take about 20 seconds. It looks both directions, runs a test, and gets some results. The interesting thing is that at the end, it's got a couple things you can click on. There's some information about statistics, and then there's one called More Details. You can see them below down here. And there's one called Report a Problem. And what that does is actually format an email that it will send to whoever's been configured for this perfSONAR instance, the result of their test. So this is a good way to start. So again, you can report it. If you see a problem, you can report it. You can get a window, which unfortunately you can't see because it's not shared on Adobe Connect. But trust me, these little boxes are clickable, and you can look at the results. And by the way, anybody out there should be able to do the same thing that I just did if you go to this URL. There's a slight caveat here. We only peer with research and education networks. So if you're coming from a commercial provider, you won't be able to get to our perfSONAR instance. But there are many, many more perfSONAR instances all around. So, I mean, I would tend to point local people to a local perfSONAR instance and run one of these on-demand tests. And it'll do some analysis and show them a result. And if there is something fishy, you can at least send an email off that will encapsulate what was observed by the test and give that to people to look at.
Okay, I think I have fouled up the Adobe Connect thing here a little bit. Okay, I was trying to make that screen bigger. All right.
So I realized I didn't fully answer Marco because there was another part to what he asked. He asked about the resiliency of the installations, and that is certainly something we've been focused on because we want to end up with something that's sort of set it and forget it. There's been a lot of work at this bottom link down here on toolkit tips and maintenance. We're trying to always improve the recommendations, and in fact, we're feeding this information back into the developers' hands so that when they produce new versions, a lot of what we've figured out is built into the package. So our goal is really to come up with something that you should be able to install and configure once and just have it run, and it'll constantly be gathering this data, and it'll self-maintain. It'll clear its databases, keeping a certain window of data available. Usually right now about 6 weeks for latency measurements and traceroute measurements, and a few months for bandwidth measurements because they take a lot less space. So anyway, a goal is to certainly produce something that sites wouldn't really have to maintain at all after the initial installation. We're not quite there yet. I mean, we've certainly hit some issues with services having problems or disks filling up or things not being properly cleaned. But I think, the good news is we're beating those down, and as this new release should be a significant improvement in terms of its maintainability.
Okay. Thanks, Sean. Any final questions? Any other questions? Okay, I think not. So again, thanks everybody for attending the meeting. Thank you, Sean, for the presentation. That was really useful. And we shall meet again in about a month.